Okay, so we will have a short lecture about Hadoop and MapReduce. And I already mentioned what the course is about, but we will do a brief overview one more time. So we will talk about overview of the course, MapReduce, and some other parallel computing systems. I already mentioned that part of the course will be about data mining. Part of the course will be about data mining, and the reason for that is because the course is cloud computing for data analysis. So we will look at the cloud in terms of the architecture of the cloud, the way it is designed, the file system that it has, the different commands that we can use to access it, and so on. But most importantly, how can we use that for data analysis? A lot of data analysis consists of data mining, which is looking for patterns and trends in large amounts of data. So we're going to be extracting some patterns or trends from the data, and we would like to extract patterns that are actionable, in a sense that the knowledge that we extract from the data is something that we can do that we can do something with it. All right? Because if somebody tells, let's say, if we buy pizza, we also buy Coke. Okay, that's good. Can we do something with this knowledge to our advantage? Can that help us to accomplish our goal? If we are a retail store, maybe we can put the pizza and the Coke together, and the people will remember to buy the other thing when they go for pizza and the Coke is right next to it. Maybe they remember to buy the Coke and buy more stuff in this way. Or maybe put it very far away, so make them go looking for it, so they can walk through the entire store and buy and look at a lot more things until they get to the Coke. Anyway, it is our decision. Can we do something about it? There is certain knowledge that is extracted. There's nothing we can do about it. For example, pizza and Coke. Okay, well, if we are a bank, we don't care about this, and we can't do anything with that. So the knowledge that we will focus on is actionable knowledge, something that we can take and do something to our advantage. Let's say we extract a pattern that says, and not only actionable, but it has to be also interesting. Because data mining will generate lots of patterns from the data, just because the data is huge itself, and lots of patterns will come out of it. And we need some way to filter through these patterns and see which patterns are interesting and actionable, and which patterns are not good for any use and might not be interesting to the user. How can we tell if they're interesting or not interesting? So extract the pattern says the humans have 2 hands. Okay, everybody knows that. That's not interesting. That's a trivial pattern. All right. If we extract the pattern that says the sun will not rise tomorrow, it will be eclipse of the sun and it will be dark all day long. Is that interesting? It's interesting because it's not very likely to happen, right? So if something is not very likely to happen, it's probably going to be interesting. There is a way to tell if the patterns are actionable or interesting by calculating certain parameters on them. So we will see what these parameters are, and we will calculate them, and we're going to sift through all of the discovered knowledge to find the interesting actionable patterns. So it says from very large data sets. So these patterns will be extracted on very large data sets, and the algorithms that we talk about do not work well with small data sets or with data sets that are not properly formatted or prepared for mining. So we will spend some time to see how the data can be prepared for mining. So we will do some data pre-processing before we can actually do data mining on it. So what we will talk about in this course. There will be machine learning algorithms as well, because data mining comes, it mixes several different areas together: the statistics, machine learning, and databases, relational databases. So all of these combined produce the data mining area. And machine learning, we will see several machine learning algorithms. That is, machine learns automatically to create some model and extract patterns from the data. So it learns on itself, whether the learning is supervised by us or unsupervised. We just let it go do its own thing. That's an unsupervised learning. So we will see how that works and what these algorithms are. The idea about this course is because it's cloud computing for data analysis, so we will do data analysis, but we will see how these algorithms can be made to work on these cloud environments, which means to work in a distributed scenario where we can have multiple machines doing these things at the same time versus a single computer, because a single computer cannot handle all of this data, or it can handle it, but it's going to take a long time, right? So algorithms that scale, it means the algorithms are well suited for expanding them to work with very large data sets and to work on multiple machines. So this parallelization, it means we make them to work in parallel at the same time. This is pretty much like your CPU when you get a CPU with multiple cores, right? It has not one CPU, but 4 CPUs in there, small ones. And supposedly each one is doing computation in parallel with the rest of them. This way the machine runs faster, right? Instead of one CPU, you have 4 cores, 4 small CPUs inside. And supposedly each one is running in parallel with the others and running the programs faster in this way. We have this exact same idea here. So we're going to have multiple computers, each one running in parallel, doing parts of our task that we gave it to do. So this machine learning and data mining type of algorithms, there will be some sort of a model that is created, and into this model we will feed the data and ask the model to produce some result for us. So this is very similar as, for example, look at some historical data, see how we performed in the past, and try to predict what will happen in the future, for example. Or look at some current data that we have, and based on the current data, try to predict what is the class of the new data, or what group, cluster group it should belong to. So we're building some model in order to predict something based on the data we already collected, or based on what happened in the past. So in one example, Google, right, the search engine, has lots of web pages to search through before it gives us the result of our query. Where we enter the keyword, and the Google has to go through all the websites in the world and give you the best one, the most relevant to the query. And so the model that they build is to compute some function to rank the pages and assign a rank to the page, to all of them. And the ones with the highest rank will be displayed to the user. In the top 10, for example, will be displayed to the user. Of course, they can look at the rest of the hundreds and thousands if they want to. But based on this model, we will return the most relevant pages and list them on the top. So this model will represent the importance of the page. How does it do that? Well, it has to build the model, so it has to look at some, have some internal logic in order to determine this rank. What is this logic? Well, it's going to look at the structure of the web, of how the web pages are linked to each other, which pages have more links, which pages have less links, and which pages are more important, or do they contain the subject that you are interested in, and compute this rank. So that is the model. So most of the machine learning type of algorithms will use some kind of a model like this. This can be to better explained with some everyday problem that we would like to solve. Like for example, college teams that compete with each other. So most teams will not play with each other, and there are some weaker and stronger leagues. So which are the best teams? If we want to predict who is going to win between teams that never played with each other, what can we do? So that is the problem. We can build some model in order to make this prediction. So that's some small data set that we have, and this is the problem we have to solve. So a model can be built. We can list the teams from best to worst and use this as a logic, or we can try to come up with some more complex algorithm to be more accurate, such as using the cost and starting with some specific order, incrementing this cost if the team is lost and something like that. So we can try to create a more complex model if we want to. So let's say this is pointing, the tail is a winner and the head is a loser. So if these two were playing, then this is the team that won. If we look at the entire graph, then this list is not very likely to be the most accurate one, so it has a higher cost, and the more accurate list will have a lower cost. So this is just an example of some model that can be built using these costs for these teams. What is the rule? I mentioned that a lot of the data mining comes in the form of rules. So rules versus models. So when I said if we buy pizza, we also buy Coke, that is a rule. It means if we have pizza, then we have Coke. 90% of the time. So that's a rule. This is the type of form of knowledge that data mining will extract from this data. So, for example, this could be used for spam filters, for email, and to compute what is the likelihood that particular emails are spam, and then create a spam filter and remove these emails from the inbox. For example, if it contains a specific string, then it is likely to be a spam. That's a rule. When you see this little arrow here, this is a then statement. If we have this string, then the email is a spam. That's what this little arrow means. So these are called association rules because they associate a specific item on the left side of the rule with an item on the right side of the rule. And we can generate hundreds and thousands and millions of these kind of rules from a data set. So to find associations, and so we do compute some measures to try to tell if they're interesting, if they're actionable and useful, or not. And remove the not good ones and leave the best ones only to show to the user, the most relevant, the most interesting. This type of rules are used for, let's say, for managing stores, let's say on Amazon.com. If you go and purchase some items, and it's going to show you underneath a list of items that they believe you might be interested in based on what you just bought, right? And so this is how they do that, through these association rules. If you like this item, you're likely to like the other item, or because 500 other people liked it, you probably are similar to them. If we create these clusters of customers, and let's say you are similar to all the other customers that like this item, then you're also likely to enjoy that item, so they will recommend it. So these association rules are used for this type of advertisements. Alright, the prerequisites I already mentioned for this course. Okay, this is not 6114, this is 2114, the undergraduate course, data structures and algorithms, some probability, linear algebra, and I listed these documents on the syllabus. You can download them if you want. Programming, Java is expected you to know Java, but we will be learning also some new languages that are used for this scalability programming, that are used for the cloud tools. So we will be using Scala language as well, which is based on Java. So if you know Java, it should not be very difficult for you to learn that. And the Scala is a very compact language. If it takes you like a one page to program something in Java, it's going to take you one line of code to do that in Scala. But we will see some examples of that. I will go over relational databases if we need them. So I'm going to explain how relational databases look like. They have rows and columns, and you can send queries to them to retrieve some information. For example, give me all the customers of age bigger than 23. Or give me all the students that have a master's degree. That's a query that can be sent to the database.